We have a monic polynomial. It's a polynomial with the leading coefficient 1. Find the real monic polynomial of the lowest possible degree, which has zeros 1 plus I, negative I, and 3i. Use z as your variable. So first note that the complex roots come in pairs. So if 1 plus I is a 0, that means 1 minus I is also a 0. And so what you do is you take the conjugate of each of the roots. So the conjugate of 1 plus I is 1 minus I. Okay, so that's the first one here. And then we have negative I. The conjugate of negative I is I. Finally, we have 3i. The conjugate of 3i is negative 3i. So the lowest possible degree is going to have all 6 of these zeros, which means this is going to be degree 6. Now the next step is putting these in factored form. So you're going to have x minus your 0. So the first one is 1 plus I. The other one is 1 minus I. And then we have x minus negative I, which turns into x plus I, and then x minus I. Finally, we have x minus 3i, and then x minus negative 3i, which is x plus 3i. So let's simplify these. X minus 3i times x plus 3i. Well, this is going to be a trick. Whenever you have a plus bi and a minus bi, that's just a squared plus b squared. So you just do x times x is x squared, and then b is going to be 3, so that's going to be plus 9. So it's 3 squared is 9. For this one, you have x squared and then plus 1, since b here is 1. And now for this, unfortunately, we have to do it the long way. And I'm just going to put it underneath here. So this one, you have to FOIL it out. So first do x times x, that's x squared, and then outside, so x times negative, or the opposite of 1 minus I. So let's do this. We have the negative outside, and then we'll distribute the x here. So it'll be x minus xi. Now inside, we can have the negative outside, and then x distributing both 1 and the I. And then finally, the last one, the two negatives going to be positive, and then this will just be 2. And the reason it's 2 is because of what we set up here. 1 plus I times 1 minus I is of the form a squared plus b squared for the answer. So that's 1 plus 1 is 2. So I'm going to simplify. I have x squared minus x, that's minus 2x. Now I have a negative xi, that's a positive xi, and then minus xi, that cancels, and then we have plus 2. So to put this all together, we have 3 different roots, or 3 different factors, 1, 2, and 3. Now you want to combine these. You want to multiply them. So let's have x squared plus 1 first, x squared plus 9, and then x squared minus 2x plus 2. Okay, let's actually multiply these out. And by the way, I know this says use z as your variable, so we're going to, at the end, put it in terms of z. Okay, so let's multiply this out. So we have x times x is x squared times x squared is x to the 4th. 9x squared plus x squared is 10x squared. 1 times 9 is 9. Okay. This one's going to be a bit long. So let's try it. X to the 4th times x squared is x to the 6th. X to the 4th times negative 2x is negative 2x to the 5th. And then x to the 4th times 2 is 2x to the 4th. Now we go to 10x squared. 10x squared times x squared is 10x to the fourth. 10x squared times negative 2x, that's negative 20x cubed. And then 10x squared times 2, that's 20x squared. Now let's move on to 9. 9 times x squared is 9x squared. 9 times negative 2x is negative 18x. And lastly, 9 times 2 is 18. So now what we're going to do is just add all of these. So we have x to the 6th minus 2x to the 5th plus 12x to the 4th minus 20x cubed plus 29x squared minus 18x plus 18. And so finally, let's put this in terms of z. So our final answer is z to the 6th minus 2z to the 5th plus 12z to the 4th minus 12z cubed plus 29z squared minus 18z plus 18.